Okay, so for today I wanted to start working on a hash table just because I was thinking that in our cool compiler it might be nice to have a hash table for these structures. And the main reason is, actually I started to rewrite a bit the logic from the semantic um checks for type checking, and I was saying that for some cases I do the exact same for loop over and over again over for example, over the classes. And I was thinking, well, maybe what if this thing will be actually like an element of a hash map instead of an array, like classes I meant. What if this would be a hash map? And basically, this class tree structure would be like the key and this is the value. But yeah, I mean, it doesn't really matter what will be the key and the value because we are gonna use functions to be like, okay, give me the hash basically, or yeah, something like that. Like we'll have hashing functions for a structure, so we'll give that to that function an entire structure, and that function should give us back an index, right? So what I'm thinking is you might have to implement that function for your structure. That might make it easier. So yeah, that's the idea of how we are gonna handle indexing in the hash table. We are gonna have a function that gets the structure that we want to store in the hash table, and it gives us back the index. So now if we go back to ds.h, we are gonna have to add somewhere around here. And so we have the dynamic array, we have, I even forgot what else I had. So yeah, basically we're gonna have a hash map or hash table, let's say. Yeah, and the idea for this one is, let's say, type def struct this h table, and I mean, I'm looking at this thing, not really impressed with it. I would actually have here, so we're gonna have a capacity. Sure, I would say, what if we make use of the dynamic array inside of the hash table as let's say the dynamic array will be because I mean, even the hash table is basically just a list or an array, but you can store as the keys, like you have a hash function and you take the key and you convert it to an index. So that's the main idea. We have a hashing function that converts any type of value into a number. So even in Python, if you have like, when you have a dictionary of objects like this, there is behind of this there is some kind of function for string. I think you can call it like hash or something like this. Don't quite remember, but I think something like this function is for almost any type of object, and it generates you an index, or yeah, something like that, I guess. Not quite sure how Python does it though, but yeah, for what I know is that this hash function is actually responsible for allowing you to have objects like this. So yeah, that's what we are gonna need. So yeah, I mean, probably using a DS dynamic array for the entire stuff. So we might need something like this. Although I would say that We don't really need to make it. Wait, where is the dynamic array? We don't really need to make it a pointer to it, so that's something. But I mean, I get what this guy is trying to do. It's trying to make like an array of arrays, basically, for buckets. But I mean, I would even say that we can have something like this for the buckets. And then each bucket can be, for example, a linked list, right? It can be a linked list or another dynamic array. It depends on how you want to implement it. Do we want each bucket to have its own length, or do we want the buckets to have a constant size? I mean, it's up to us pretty much, but what I'm more interested in is that hashing function, right? So let's say that we're gonna have a dynamic array of buckets, and we'll figure out how the buckets will look like. So basically, yeah, I mean, although the yeah, I mean, it's not really the yeah, I mean, maybe we can have its own thing, because dynamic array doesn't really have a way to index into it. Although, yeah, I mean, it does, but it doesn't really have a way to add at a certain index, something like that. It's gonna be used more for just putting stuff into it. So yeah, actually, we don't really need the count. That's the main reason. We don't really need a count, so we might be able to wait. I missed it. So we might even be able to use a linked list, let's say, and we might need an unsigned int for the capacity. But see, I don't think we need the count. Capacity. We might need the capacity. Just the capacity, like it's more needed to have a vector structure rather than the dynamic array. So we're gonna have the capacity, which is the full size, and we might need to have pointer to something. For example, to the linked list, let's say. If we want to have a linked list of items, but I mean, we could also use the dynamic array pointer to buckets. So yeah, something like this. Let's have a dynamic array. Should be easier. And I think that's most of the stuff, right? So we have basically an array of dynamic arrays, and each dynamic array is a bucket, right? And the idea of the bucket is basically if our hashing function gives us the same index for one of the keys, we have to resolve that collision somehow, and the easiest way is to use a bucket to put multiple keys in the same for the same index, basically. So let's say that in this example from here, John Smith and Lisa Smith would give us the same index, 0, 1. So we would put inside the bucket both of them, right? And then when we search for one of them, we get the index first using the hash function, and then to choose between which one to select, we use the key directly, or like we compare the keys. So the next thing that we need inside of this ds hash table is a function that does the hashing, right? So something like this. It returns an integer, unsigned integer, and it takes in anything basically, which will be structure, stuff like that. Then I think the next thing we need is the item size, and that's also something from here in the dynamic array. We need the item size to be able to initialize the buckets, right? So item size. Yeah, we need, let's put this thing like this, something like this. So we have the buckets. How big is one item? The capacity, the hashing function, and yeah, I mean, we could try to implement the hashing function on our own, but as I said, we're gonna store the structure entirely, so we don't know which is the key and which is the value. But we can create a macro that always searches for key, and you are forced to name your key as key. But what if you want to have a more complicated hash function for some reason? So let's keep it simple and make the user implement their own hash, basically their own hashing strategy, let's say. So is that everything, I guess? Like, we might also need a way to compare the keys, right? Like another function that would be comparing two keys, or like comparing the structures, because when we have a collision, we have to use the keys themselves. We no longer use the hash. So I think these are the main components of the hash table. So let's have a init function. Okay. So this is hash table init, and let's leave Copilot do it. So it's basically, we get a hash table, item size, the hashing function, compare. I would also put there the capacity, because the capacity is something important in the hash table. Okay. Because it's never gonna change, pretty much, the capacity. Right, like it's gonna remain the same. So yeah, I think these are the main components, right? It's a bit more verbose, I guess, because of these two things that you have to implement. But yeah, I mean, for compare, I would probably just use mem compare, like mem cmp, and use the item size as the size, pretty much. And for the hashing, but yeah, the problem is you would also compare the other stuff. So yeah, maybe something else that we can try to do to go around this thing. Let me see, because I think, oh yeah, we have ds mem compare. Oh, it's mem copy, sorry. So yeah, we could also ask for the key size, for example, key size and value size or something, and force you to have the structure something like struct ds key value, something like this, right? So you would have to use the key value pair or something, or hash table entry. That's a good name. So you would have to use this thing, right? Maybe something like this, and we are gonna know that that's the size of what's inside of the bucket. And maybe instead of item size, we are gonna use key size and value size, and then we are gonna be able to implement hash and compare ourselves. I guess we no longer need the user to provide hash and compare, right? Because it's gonna be a bit easier. So something like this, capacity. And how about here having key size and value size, right? Something like that, because we are going to use this thing. And obviously we could have two arrays, one for the keys and one for the values. Keys and another one for values, just to store each one individually because it might be easier. And here let's say key size, value size, and also the capacity. As I said, the capacity is gonna be mandatory. So yeah, we can actually, we don't even need a structure then. If we can say something like this, void key and void pointer value. Yeah, let's make it like this. It looks better. So we're gonna have insert, we are gonna have get, and basically get, you give the key and the pointer to where to place the value. I think we are gonna use like get, which gives you a copy, and also get ref, right? Yeah, I did this on my own with get ref. For dynamic array, you get the reference to that place in memory, so you can modify the array itself. If you use this one, you get a copy of that item, so you cannot modify the array. So let's have get ref. Basically, get ref is gonna be here a double pointer because we want to get the address of that value, and void pointer is just value. And remove, and obviously free. Okay, so we don't even need that thing then. So we have everything now. That's nice. So let's say we need a dynamic array. So how are we gonna do this? Define ts ht implementation. Okay. And we might need a condition here. If ht implementation, define the implementation, and end if. So this is like if you want to have the hash table implementation, you also need the dynamic array implementation, right? It's like a condition. Requirements. It's like you are using npm. So and I forgot. Why did I define this twice? Strange. Oh, it's node. Sorry. Yeah. Okay. Anyway, so let's put this stuff in here. So just wanted to see how I did it for other stuff. I put the documentation myself, That's the most boring stuff, but I mean I generated with ChatGPT, so it's quite fast. The implementation. Okay. So first of all, how are we going to initialize the hash table? We initialize. Wait 1 second. This is a pointer, so not really smart. We have to alloc the dynamic array. So what I would do instead is say something like hash table keys. We have to allocate size of this dynamic array, capacity multiplied with this, right? We have to allocate it. I know we have realloc defined like that. Mem copy. I thought that we also have stuff like mem compare and or I mean mem okay, mem copy, yeah. So if you don't define mem copy, then it's gonna be just like that. Oh, but it's, yeah, I mean, whatever. I have to see how I'm gonna fix those things. So I mean, we malloc the keys, right? We also have sure enough error handling. We also have to malloc the wait, init should man, all these things. I mean, priority queue, stream builder. I thought that I mean, if well, yeah, I mean, if that thing can fail though, it should be an int, right? Because it can fail. So something like this, and let's say int result, and have here a defer. You can return defer. Okay, something like that. Here we have to do the same thing. Yeah, I mean, we basically have to allocate all the keys and all the values, and then just dynamically init all of them. And set the key size, set the value size, and the capacity. Just those things. Yeah, I was just thinking to make them 0, but key size and value size. Okay, it's all good. Yeah. Okay, so basically the init, we just initialize the keys, the values, pretty much the same thing as all the other data structures. So now for insert, let's see how are we gonna do this. Yeah, well, we're gonna need to define a hashing function. So static, and let's say unsigned int ds hash table hash. So let's leave it empty for now. Return 0, and let's do question marks. I love that. Implement hash function. Okay. So first thing we need to do, I think, is to generate the I mean, let's put differ and stuff. We need to generate the index, and let's use the hash table, or I mean the hash function, and we are gonna pass the structure and the key. And why we need the structure here is for the size of the key. Right, we're gonna do something on the bytes of the key, and we need a size. We need to know how many bytes we have in the key. And we modulo by capacity. I mean, we can do that inside of the hashing function, but it's pretty much, I mean, obvious that we are gonna do some hashing, right? Okay. Like we need to make it between 0 and capacity. That's why we modulo with capacity. Okay, so we get the index. That's nice. So yeah, basically now we need to copy the key and the value inside of the thing that they need to go into. So we get the bucket, so the keys bucket. This is a keys bucket. We also need the values bucket, and what we are gonna do is just dynamic array append. I think this stuff also returns 1, so we can do 0 if successful and 1 if didn't work. So we can do something like if this thing keys and key is not equal to 0, fail to append, but I think this also shows an error, so whatever, we can show how many errors we want. Then we have to append, okay, I mean, let's put something like this to make it. So first we take the keys and we append our key inside of the bucket, right? And here we append our value inside of the bucket. I mean, what's gonna be a bit more meh, it's gonna be deleting stuff. Let me check if the linked list, if I did some, oh my god, if I did some delete for a linked list. So priority queue, we don't care about that, so it's where is linked list. So we have just pop from the like front and back. We don't really have a remove, right? That sucks a bit because we are gonna need that. So yeah, we might implement it here for the dynamic array. We could have also used the dynamic linked list and implement popping from a random spot, but that's a bit inefficient. I mean, even in this one, it's going to be inefficient, so it doesn't matter. Deleting stuff, right? Let's see though. So here we append. Like, how are we gonna remove stuff? Yeah, that's a good question. I mean, yeah, sure, fair enough. I mean, for the cool compiler, we don't even need to remove from the hash table, so we don't care about it. Anyway, here, yeah, we inserted stuff, and it also handled the bucket, right? It didn't complain about anything. So I think that's everything for the insertion. We just inserted the key and the value at the index, so we have that. Okay, perfect. So now getting a value from the hash table, So again, we might have to do something like this, defer the result, and here we need to take the index, right? We now need the keys, right? We need the keys and also the values. But what do we need to do now with the keys? Is to get a for loop, but we need unsigned int. I mean bucket size, but I wanted the bucket index pretty much. It's gonna be 0. So for yeah, it makes sense to get the values and do it without the index. So it's gonna be for unsigned int I. This is the bucket index. It's 0, and we have to go up until the keys count. So let's see, I don't want to use memCompare like that directly. I mean, so we're gonna have void pointer k, then we have not sure why you wouldn't use ds dynamic array get ref. Wait, what? Let me see. ds dynamic array get ref could be used, I guess. I mean, we don't even need to get the ref, we just need to get. So like put here the keys I and the key k. So this is gonna be null. Well, it's because we cannot. Okay, so we have to get a reference. Get ref. We're gonna get the reference to k, right? And now we have to do memCompare. But as I said, I don't really like to have memCompare directly. So basically, if let's see, so if not defined no standard library, we are gonna have to also define ds mem cmp. But so this else, yeah, right. So we do memCompare like this, and let's do just for the memes define ds no stdlib just to see how it looks like on the other side. So we have to define all of them. They are not defined. That's good. So we have memCompare, memcopy. We also have to define if not defined ds memCompare, we can use just the same thing as we did here. We have to get the result, we do a for loop, and we have to compare each byte individually. Basically. Okay, and it does it with minus. That's pretty cool. So then we have to end if it. Yeah, so the idea here is if you want to not use standard library, you have to define malloc, free, and exit. And all the other stuff is optional. Basically, realloc can be implemented using malloc and free, I guess. and the mem copy. Yeah, and yeah, mem copy can be implemented just as a for loop, and the mem compare is also just a for loop if you don't want to implement it yourself. So that's just making stuff a bit easier. So like if you want to use this in WASM, this ds.h in WASM, you would have to implement just malloc free and exit, which I mean exit doesn't do anything on WASM. So I mean you would just reset your program to its initial state or something like that. So here we have to just mem compare the key that we are on inside of the bucket. So yeah, now we iterate over the bucket, over the items inside of the bucket, and if the current key from the bucket is equal to the key that we are searching for, then it means that index I is actually the value that we want to get. So we just get it. We place it inside of here. So that's the idea. And we also exit with exit code 0. And here we cannot find. I mean, I don't know if I want to show an error or just return it for 1 maybe, if we cannot find it. Okay, so pretty easy. Next thing is to do the same thing. I mean, it's pretty much the same thing, but instead of here getting, see, like before it was get, right? So we want to do get ref, and just that's the only change basically, because get ref gets a double pointer. So yeah, that's that. Then we have hashtable remove and hashtable free. Let's do free first because it's easier. And yeah, I mean, we just call free on each bucket and then we free everything. Okay, so deleting from the hash table, I mean, let's just ds log error not implemented, return 1. I mean, if we are gonna need it, I'm gonna implement it, but for the purposes of yeah. I mean, I would have to also implement ds dynamic array remove. So yeah, let's see how are we gonna do the hash function. That's a good thing to think about. So let's see in Wikipedia if we have anything load factor and stuff. So hash function. I mean, usually I would just modulo stuff around, and you have to use a prime number to do some stuff. I mean, I would like to see if there was anything here. It's collision resolution, whatever. I mean, as long as we have something, it doesn't really need to be efficient. Like, okay, M is the digest of X. But what I'm curious about is how do we get this digest of anything? Like, I mean, one idea how I would do it is unsigned int hash is gonna be 0 first. And how about just adding all the values of the, like all the bytes from the key or something like that. And yeah, basically, let's see. Okay, I mean, that's like something, doing some random stuff on the key. But I was thinking, what if we do something like hash times, okay, fair enough, like times 31, or like a random number, and we add the current byte from the key, right? So that would be something, and then we return the hash. So this would be my hashing function. I'm not sure, probably it's pretty bad. We could also try to, like, here it says something about the load factor, and this is let's say n divided by the number of buckets. So how many items we have divided by the number of buckets. But I would also like to see how many empty buckets we have, something like that, or how many buckets with stuff inside versus how many empty buckets we have. Like, that's also something interesting, I guess. Yeah, whatever. So yeah, I mean, you would also have more complex stuff. Like, if you go above a certain load factor, you uh, increase the capacity of the hash table. But yeah, I mean, that's stuff that's nice to do. But let's go into examples, and let's try to build a hash table.c. So let me just copy paste, the array example or something, and let's do ht implementation. And as you can see, we also have the dynamic array since we have ht. Anyway, so let's do something like ds hash table. Wait, is it not hash table? Yeah, it is hash table. So let's call it ht ds hash table init, and we need to provide the size of the key and size of the value. So yeah, I mean, the only see, like, the problem maybe is that here I said the size of the keys is always gonna be constant. But what if we want to put strings as the key? That's gonna be a bit more difficult, I guess. So, like, you can only have size of, I mean, you can have size of char pointer, right? But it's not really gonna be, the hash is not gonna be based on the string itself. So that's not really optimal. You are gonna get the key, but we don't really have the size of the key. I mean, let's see what happens. Like, this, what's gonna be like the error. So let's do 100 stuff. Okay, save something like this. Ds hashtable free. Let's try to make this. Okay, so for remove we don't care about it. So let's do build hash table. So we don't get any errors, right? First. But yeah, I guess here if you have key size, it's gonna work for stuff like structures and stuff like that. But if we are gonna have, let's say, a char pointer, like we want to use like a string with any, maybe a string with any kind of value. We might need to have some other logic instead, because we provide like the key size, but this is gonna be size of char pointer is gonna be 4 or 8, like the memory size. It's not gonna be the string length, right? So my guess is for simple stuff, it should work with the key size. Like it shouldn't have any issues. But if you want to use the memory itself, like the bytes of the string itself, it's gonna be a bit different. So let me think about it. Like we can convert now. Like yeah, I guess the original idea with the hashing function was actually better. Or maybe it's something like if you provide the hashing function, we use the hashing function, and otherwise we just do the basic hashing from here. But let's just try to add stuff into this. So let's have a char pointer key and value. Let's do is hash table insert key and value. And how can we print this thing? So for int I equals 0, I is less than like the ht capacity. If ht, well, I mean it's another for loop. For int j equals 0, j is less than ht dot keys of I dot count g plus plus. We take char pointer k is gonna be, man, it's gonna be maybe something like this. Ds dynamic array get, and here we need to provide the keys. Okay, let's do printf key. Let's see what happens if we do this thing. So we get the key back, right? And let's also get the value. And let's have something like okay, key and value. So these are stored. Oops, didn't work. I wonder why. Oh, because it's an int value. Well, I mean int b. No idea why it's like that. Okay, okay. Okay, so we get the key and value, right? And let's also see print index and the key and the value. So like this would be, index would be the value of the hash, right? And this is the key and the value. But what if we have a char pointer find key, and this is going to be key, and we do something like hashtable find, or was it hashtable get? What? Hashtable get, yeah. And let's say if this is not equal to 0, wait, key and int value is gonna be, no, value is gonna be equal to 0 or something like that, just to reset it. So this one returns 0 on success. So if it's different than 0, it's error. So yeah. Oh yeah, I actually found it. Interesting. What? I mean, I was thinking that inside of get, you see like the hash was different this time. It was 81. Hash table. So, I mean, I guess it was lucky because, yeah, I have no idea how it found it. But, I mean, like my guess was that the address would be different enough that it's not gonna find it, because or I guess the other thing that happens is let's make the key a bit larger, like larger than 8 bytes. I mean, let's make it the same, and I think now it shouldn't work. My reason for why it wouldn't work is well, here we get the address, like we get a char pointer. When we do when we do hash, we get char pointer, for example, here, and the size of, like if we printf size of char pointer, printf percentage zu size of char pointer, like it's 8, right? So it's just gonna search. I mean, when we insert stuff, I think dynamic reappend does a mem copy, right? Yeah, so it copies what's at that address. So it copies that thing into there. Yeah, that's pretty strange. But I mean, maybe the other experiment is, what if we put here an N, for example? I guess that's what I wanted to do. Whoa. Because it also does mem compare. But if we take a look, at the index that we get here, even though it doesn't find it, it's gonna be the same. Damn, I have no idea how it works. Because, yeah, damn. Because here we are gonna get, like, we get the string, right? We get the char pointer, and when we do hash, we don't use the size of the string, we use the size of the pointer size, like 8. So it's gonna, I was like, we would as well print f each character and see the characters, right? Like we get some random trash there. Well, I would print it as a D just to see it better. Like we just get some random trash, right? If we try to print f it as a string, it gives us this. But why doesn't it work? Because it's that's a bit weird. So when we do hash, yeah, like when we do hash, okay, let's think about it. So here we pass the address of the key, so it's a char pointer pointer. Actually, when we do insert, this is not a char pointer, it's a char, is the pointer to the char pointer. Okay, so let's say that we convert it to so it's char pointer and we get the address. Wait, it should be something like this, and then we dereference it. Yeah, we have to do that. Okay, so basically it's here the key would be the address to our string, right? It's not the value itself, it's just the address. So here we convert it to char pointer, which is the address. But since there we have like key size, it's yeah. So like the only option would be maybe to have, let's say, like a constant size for the string. Like that would be one option, to have a constant size for the string. But I mean the easiest option would be to just have a custom checking for the hash table, because even here when we do mem compare, I mean here we actually compare, but we still compare. Here we also get char pointer pointer, so we get the address to the string, so we compare the addresses. So even then this doesn't work. Like this would only work if you have, I don't even know. Because yeah, here you get the address. So like maybe something else we can do is here, let's say we convert it to a void pointer, and now we send the value of the key, right? But here comes the issue, and that's here we said, well, we are gonna have pointers to characters, so that's not gonna work, right? So yeah, like here, if you have char pointer, this should have been only like the actual size, so that's why it's not gonna work like that. So yeah, I mean, the other option is, as I tried earlier, let's go to this thing, and yeah, I mean, would be to just have the function itself to do the hashing. So that's one option, and yeah, I mean, this would work, but not for our use case. So let's see, how can we do it? Can we, I mean, you cannot really say the size of the key each time you do a comparison, right? That would suck. You cannot really do that. I mean, in the dynamic array that we have, we can, yeah, let's just do, so we have unsigned int, and here should be the hash function, and maybe an unsigned, well, it's an int compare function. So here we can say something like index is equal to 0, and if ht hash is not equal to null, then we do something, and else we do this. So here we compute the index like that, and here we compute the index using the simple hashing function. Right, something like this. So this would fix the issue there. And probably the same for this one right here. So for the other one, is the same thing actually. So yeah, I mean, let's just use only this one. Let's not care about the other stuff. Let's just do it like this. So this was getref. This one should be something like this, and this one should be something like this. Let's see. So now it should complain. Well, it doesn't really complain. Let's remove, I mean, we are not gonna need, well, actually we are gonna need the key size and stuff because of the dynamic arrays, but yeah, we're gonna have that. So we are not gonna need, yeah. So this thing then should also take in the hashing functions. So let's see. Let's put, well, let's reformat the stuff, and here we need to set the hash and compare. Okay, so unsigned int hash, and we are gonna get here we are gonna get a pointer, so it's gonna be void pointer key. Was it a const? Don't remember. Yeah, it could be a const void. Why not? Let's do a const and a const void. So yeah, this is gonna be, but see, this is gonna be the others. So let's do something like char pointer k is gonna be something like this. And that sucks. I don't know how to make it. Yeah, I mean, let's say something like this. And int compare could be const. I mean, even this one can be until strlen. So yeah, hash and compare. Wait, what? Oh, it's const void pointer, and I think also const void pointer here. So let's just copy paste this over the other one, and I think let's see what happens. Okay, so here when we do insert, let's see if this fails. Okay, that actually fails. Oh, yeah, I mean here let's pass the value like that. Okay, so here now key N doesn't work, but if we put key A, it should probably work. Yeah. So yeah, I mean now we have a hash table. The only downside is you have to define the hash, but I'll try to see if I can do it on my own to be able to not have to define the hash. But for now, yeah, you have to define both of these, which sucks a bit, but hash table, yep. So yeah, I guess now we'll be able to continue with the compiler, or at least I'll be able to change some stuff, and see you guys when it's gonna be more interesting on that topic. So yeah, that's pretty much all for today, and see you on the next one.